So the logarithm is the inverse of an exponential. And by definition, if we have any positive b where b is not equal to 1, then we say this hokey pokey. Now, of course, none of this means anything to you. All you recognize is that there's this new thing called a log. And all your life you've seen that button on a calculator, log. And somehow, notice that this thing has no exponents, but this one has exponents. So you know that this is an exponential. And somehow that can become this, which is called a logarithm. Now, this a right here has a special name, and that a is called the argument. We say that this b right here is the base of the logarithm. So we can have multiple kinds of logarithms with different kinds of bases. We can have log base 2, log base 10, log base e. Now here's where I teach you some bootleg math that I've created. Every textbook that you'll encounter and that I've encountered always has this little paragraph with this little thingy and little arrows that tells you, okay, well, this goes here and this goes here and this goes here and that goes there. And if you want to go backwards, you do, all this weird stuff. That didn't work for me. I mean, it did when I took the class, right? When I took Algebra 2. And then when I took pre-calculus, I forgot it and had to go through this whole thing again of what the book showed me to do with the arrows. And then I forgot it. And in calculus, when I had to use logarithms, I had to remind myself of how to do it again. And I would forget it. All throughout Antelope Valley College, each time I took a math class and I had to use logarithms, I had to remind myself of how to do it, because I would forget. UCLA, mathematics major, same thing. I would forget. So I got tired of forgetting, and I created my own mnemonic device. So take a moment to reach for your elbow. Touch your elbow. Hopefully you have an elbow. And if not, go find somebody else's elbow. But it's called e.l.b. And since creating this, I never forget. I know exactly how to move a logarithm into an exponential or an exponential into a logarithm. So touch at elbow, e.l.b, 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 e.l.b. That's how we're going to remember to do this. So the full phrase is the exponent is a logarithm of the base. So the e, right, is for exponent. The L is for logarithm. And the B is for base. And those of you taking SAT tests and stuff like that, e.l.b is going to be a lifesaver. So the exponent is the logarithm of the base. So please just watch, stop writing things down right now and just watch the whole thing unfold, and you might want to pause and replay this a few times before you write this down. But let's take, for example, the original problem, right? Well, what is the exponent? Literally, it says the exponent. Well, the exponent is x. So the exponent means x. What does is mean? Oh, right? What does logarithm mean? Oh, it just means I write the word logarithm. And if I look at this exponent, what is the base? This is the base, right? This is the base, and that's the exponent. Base. So the base goes right here. What's left over is the argument, and that goes right here. So what this little thing is telling me is it's pretty much telling me how to lay things out. So let's say I have this exponent right here. This exponential, I should say. Well, if I follow e.l.b, e.l.b, and I want to write this as a logarithm, I take the exponent. So in this case, the exponent is 3. So the exponent, right? The exponent is the logarithm of the base. What is the base? 5. Where do my leftovers go? So for those of you waiting to do some real math right now, we haven't done any math. This is just reorganizing. This is just taking exponential equations that you've seen before in the past and rearranging it into some new mathematical entity called a logarithm. Okay? And I'm hoping that you can use e.l.b to always remember how to do this. You do not need to refer to a book or to a diagram or to a bunch of arrows. You can see every video out there. You can see every book out there, and they will show you arrows going everywhere. And that did not work for me, a mathematician. It might work for you. I hope it does. But regardless, you don't have to worry about that because I'm giving you e.l.b. The exponent is the logarithm of the base. Now, this little saying here is not technically mathematically kosher, but it gets the job done. It'll help you to rearrange an exponential into a logarithm, and as we're going to show you here soon, how to rearrange a logarithm backwards into an exponential. You might want to pause the video, rewatch that little section, and then rewrite it. Problem 2. So let's take these and write them out as logarithms. Notice something here with this little saying that we say. The is, right? This divides the whole thing in half because the is the equals, right? So you're going to have the left side of the equal, which all it has is the exponent, one number or one letter, okay, on one side, and then you have the logarithm of the whole thing on the other side. So that's the order of how this works out. So part A, what is the exponent? It's 2. And it is equal to log base, in this case 5, of 25. That's it. We're done with A. There was no math, people. There was no math. We're just rearranging things. We're just rearranging your room. There is no math. But Mr. Over, I can't do fractions. Don't worry about it. Logarithms don't care. Okay, so what's the exponent? 3 over 2. Is means equals. Log means just write the word down, log. Okay. What's the base of this logarithm? It's 16, because that's the base of this exponential. And then the 64 goes here as the argument. That's it. We're done. There was no math to do. Don't we multiply by 2? Do we divide by 3? Do we multiply the reciprocal? No. None of the above. We're just rewriting an exponential into a logarithm. C. You're thinking Mr. Over is backwards. It's okay. It's okay. That's what we're doing part C, because it's backwards. What is the exponent? 2/3. Yes, the exponent is 2/3. Hopefully. Okay, 2/3. There you go. Exponent is log base 16. How do we know the base is 16, Mr. Over? Why isn't that x? Because the base is the big number that has a little hat called an exponent. So if something has an exponent, then whatever has an exponent is called a base. So the base is 16. And then this x happens to be the argument. Now, just a quick little thought. I hope you would be okay with me flipping this around. So for example, I know this is how I have the sentence, right? It's in this order. And it's good to have it in the order because e.l.b, right? Your elbow, it's e.l.b. It helps you to remember what goes where very easily. However, don't be alarmed if you see it like this, right? You should be comfortable with see it the way we did. But what if they put the 2/3 on the other side instead? That's perfectly fine. It's still the same equation, right? We say that 2 plus 2 is 4. Could we say that 4 is 2 plus 2? I sure hope you can. Otherwise, email me. So be comfortable with us, also expressing the logarithm form in this format. Negative exponents, snap diggity. It's okay. It's okay. It's okay. Just breathe. We got this. The exponent is -3, is log, the base is 2. The argument is 1/8. Usually when I have a fraction for an argument, we would do well to use parentheses so that we don't get confused, right? Some people might think, oh, well, the 2 and the 8 are 28, or 2 times 8 is 16. No, 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 no. This 2 is something very different that we do with it mathematically. It's expressing to us a base, which we can go into later. For now, you just need to recognize that this parentheses is taking care of the argument. And for the record, this is not multiplication either. This is a function. Remember back in the day how we had f of x? It wasn't f times x, right? It was a machine that we put a number into. So we have a logarithm machine, okay, in this case, that's getting something inputted into it essentially. Part E, Mr. Over, we can't do e.l.b. Why not? Because there's no exponent. Why not? Because there's a little number. Why not? Because, well, we don't have a little number. But do you remember what a square root is? What kind of an exponent that is? That's a 1/2 power. And if you don't recall that, you need to go back to the previous video topic on exponentials and how we use square roots, cube roots, etc. to show rational exponents. So, you're right. We can't do e.l.b. if we don't have an exponent. So, let's force an exponent like we did in part E. Okay? Now we have an exponent. Now we can do e.l.b., right? The exponent, 1/2, is equals logarithm, base 64, argument 8. And again, be comfy with me writing like that as well.